Hello, can anyone please confirm the audio and screen share before we get started? Please say something in the chat to get started. Okay, thank you guys. Hello everyone, welcome to Big Bang Data Science Solutions, the NLP free 10-week program. And let's go over what we covered so far. So in week number 1, we talked about the importance of learning data science. It was an introduction to data science, data analytics. Then in week number 2, we talked about an introduction, the most needed or the most common 6 Python packages used in analytics. Then in week number 3, we moved into an introduction to natural language processing NLP part 1. Then in week number 4, we moved into another a continuation to an introduction to NLP, natural language processing part number 2. In week number 5, we learned about how to extract features using feature extraction methods. Then in week number 6, we learned how to develop a text classifier, an algorithm to classify text. Then in week number 7, we learned how to extract to web scraping using API, extract data from webs using API. And today we are going to move into an interesting topic. It's called topic modeling. So we'll talk about topic discovery, how we can discover some topics within a document. Then we are gonna design or implement this modeling. Then we are gonna learn about the most 3 common known algorithms related to topic modeling. We'll be talking about LSA or LSI. Then we'll talk about LDA, latent direct allocation. Then finally, if we have time to this extent, we are going to cover the hierarchical directed process (HDP). So this is the plan for today's session. It should last for 2 hours, but hopefully I should dismiss you before that. Excuse me. Okay, so let's do a short recap of what we covered so far. Okay, so today we are going to talk about a recap on the NLP pipeline. Then we are going to do a recap on NLP extraction. Then before we move on to the topic modeling, which is the topic of today's session. So a few terminologies that you should be aware of when dealing with an NLP. I am not going to explain them because we did in the past, but they are worth knowing, so you should know them, explain them, understand them. Mainly corpus, stop words, unstructured text, tokenization, natural language processing, term document or term document matrix, supervised learning, unsupervised learning, stemming. And of course there are a lot of big words, terminologies that you should know, but this is some not an exhausted list of what you should know in terms of NLP terminologies and lingo. We talked about NLP pipeline, the process, the tasks involved in the conducting an NLP project end to end. So we are gonna basically we have a raw data. A data comes in either a speech format or a text format, and they might not have a format. So what we have to do, we need to simply start cleaning this data, preparing this data through tokenization, removing stop words, punctuations, numbers, special characters. Then stemming, we need to keep only the root of the words and remove the affixes and prefixes. then we normalize. Then after that, we transform into what we call structured format, where we have rows and columns through many transformation methods, and the most common one is TF, IDF, word of bag. I'm sorry, bag of word is another one. And finally, once we have a structured tabular format data set, then we can apply any scientific method, any algorithms, any modeling. We could apply supervised learning, and we could also apply unsupervised learning techniques. So this is the typical flow or workflow that deal with an analytical project or to solve a problem using the NLP. Again, we started with the unstructured data, a structured data where there is no format, there is no known format, there is no rows, there is no columns. The data go through many pipelines of pre-processing pipelines to prepare, fix it, get it ready for transform it into a structured format. Then finally, that what we are going to use for analytics. Once we have the format that we are familiar with, once we have a format that can be used for statistical analysis, for machine learning, for modeling, then we will start applying the learning algorithms that we are planning to. So this is a typical one way to pre-process your data. You are going to tokenize your data, means you need to split your data into words, that searchable words, so to help us navigate through them one at a time, searching for stop words, common words, words that wouldn't add any value to analysis, looking for punctuations, searching for the numbers and empty or white spaces, and remove them and leave only words that would bring a value, that would have an insight, rather than using everything, which we could do that, but it would slow the process, number one. Number two, we would end up having nothing, because all what we have is a garbage, is common words, is a common raw data. So once we tokenize that to help us handle the process of cleaning, then we might need to remove affixes and suffixes from the words by applying stemming and lemmatization methodologies or concepts or processes, which we learned earlier in the previous sessions. After that, then we start applying some post-tagging to help us understand the true meaning of a word within its context, before, of course, we start retrieving, extracting information, extracting hidden insight, etc. So this is again, this is a typical analytical workflow. We start with the raw data. It could be structured. Either you are using this for an NLP or for regular basic machine learning project. You start with the raw data. We start with resources first. Data could be anywhere. It could be scattered everywhere. It could be in one location, in one shape, in one structure. It could be in many files where we need to collect data by merging data, by extracting information from specific location and making one out of it one simple data set. So once we have data collected, of course, we are going to go through a lot of wrangling, munging, ADA pre-processes to transform a raw data into a ready-to-go data. And after that, then we can apply any machine learning, deep learning to extract a model, a statistical model, and that model is what we are going to use later for deploy or to deploy into production. After we have a model deployed into production, of course, we need to keep an eye on it by monitoring its performance, comparing its live performance to the performance obtained when we had that model in the test environment. And from time to time we might need to shut down the model right on the fly and update it with a model that we are building simultaneously, while we have a live model, while we have a model in live that running that was up and running or is up and running. At the same time, we still need to keep building a model, just in case. You never know when the model is going to break. We never know when the assumption of the data is going to change, so we have to keep always ready for the worst case scenario, to shut down the model, replace it right on the fly by a challenger or challenge model that was built simultaneously while the winner model is still live, up and running in production. So we also learned about structured data, unstructured data. Unfortunately, the data might not be in one structure, in one shape. There are four most common structured data. The structured data is the most common data, the most needed data, the most used data for analytics. In a structured data, as you see in this example, we have rows and columns. It's easy to navigate through, investigate, to find hidden patterns, to find the relationships between rows and columns, between columns and columns, and between features, between all the elements of the data. It's easy to find these relationships, find the patterns, because of the format, because of the structure of this data. Then comes another structured data. It's called semi-structured data. It's closer to be, it's very close to be structured data, but it requires little effort to transform it into structured data. And an example of this type of data is HTML, where you see there is a kind of organized format, but it's not tabular, so it does require little effort to transform it into a structured data. And the third comes the quasi-structured data. This requires a lot of work compared to semi-structured data. In the quasi-structured data, we have a text, but it's in the format of clicks, like click streams that contains a lot of inconsistencies in the values and the format, and it requires a lot of work to clean it, pre-process it, prepare it, and transform it into a format that is going to be desirable for machine learning. Finally, the unstructured data. And 90% of organizations' data is in the unstructured format, in a format that is not supported by many machine learning algorithms, by many models. So this unstructured data, it could be a PDF, it could be an audio, a video, it could be an image, but we have to transform it. There are many ways to transform. There are many transformation methods, depends on the format of the data that we would use or we could use to transform this unstructured data into a tabular format, rows and columns that we can use for our analysis. So today we'll talk about topic modeling. There is a lot. Topic modeling, they are very, very complicated in terms of the mathematical initiative behind them. There is a lot of math behind them, which I am not going to go through because that would confuse a lot of us. So I will simply try to explain the topic modeling from I would say the business side, from the not from the technical, from the applied technical side, not from the mathematical side as per se. Excuse me. So topic modeling is a technique used in text mining, which provides method for identifying occurring words to summarize a large collection of textual information and connect those words to to help us get discover hidden topics. That is simply what is this topic modeling. As you may already know, a document is simply contains many words. Some of them might be unique words, means they appear once. Some of them might appear many times. So if we were to get the most common words, can we extract a topic out of this? So, and that is what all this topic modeling is about, is finding the most common words of the in a document, and out of those most common words, can we extract a topic that can help us to determine the genre of the document. Without reading a document, with that topic can summarize the entire theme of the document without reading of document. And this is a very useful technique when you are dealing with thousands of documents. Like, for example, if you are a recruiter trying to fill a position and you have thousands of resumes, and if you were to spend 1 minute per resume, that is 1,000 minutes, and of course that is a lot of time that you will be spending in these resumes, and you might not get the right person you are looking for. Is there a better way to handle these 1,000 resumes in a professional way, in an automated way, and within a time limit, in a very short time? And this is where the topic modeling comes into the picture, to help us minimize the time to navigate through documents by simply modeling, extracting hidden topics within these documents. So, for example, I'll give you a very simple example. Let's say that when you think about data science, what do you think comes to your mind when you think about data science? What technologies, what comes to your mind? Of course, there are many terminologies, many applications, many programming language that would come to your mind. If I tell you, or if you get to know someone that are scientists, and if you are in the field, then this person knows pandas, for example. This person knows Python. This person knows Tableau. This person knows machine learning. This person knows deep learning. This person knows R, modeling. He knows ML ops, and etc. So this is a topic. This is a topic, and the topic contains a group of words. So a group of words together can make a topic. Let's say that you are talking about healthcare, for example. So when you hear the word healthcare, what do you think comes to your mind? Of course, there are many words. You could think about ambulance. You could think about hospitals, nurses, doctors, surgeries, death, CDC, etc. There's many words that should come to your mind. So healthcare is a topic. Healthcare is a topic, and this healthcare is a combination. It does reflects many words. Similarly, when we have a document, for example, let's look for resume template. For example, let's grab a resume online image. So this is a resume. I'm going to grab this. So we have a resume here, and for this resume, as you see, so let's say that we have 10,000 different resumes. This is one, this is second, this is third, this is fourth. Let's assume this is all different resumes, and every resume has at least 10,000 words. And out of these 10,000 words, we have at least 500 unique words. Okay, so is there, I mean, as a recruiter, it is going to take you forever to to screen through all these resumes to try to find someone to fit who's good fit in for your who's good fit for the position you try to fill in. It is going to take a lot of time, a lot of energy, a lot of effort to do so. So the topic modeling, what it does, so number one, we have topics. So in mind, let's say that we are looking for data science, and similarly we are looking for let's say DBA, DBA. We are looking for someone for Tableau developer. We are looking for DevOps, etc. So we are trying to fill out many positions, but we don't have to. And for every topic, it has a buffet of many words, and that construct this topic. So we have a list of topics, and we have a corpus. A corpus is simply a collection of documents. And these documents, they are all they are searchable, digitized searchable documents. And the first thing we gotta do, number one, is tokenize them. That means we need to split all the words, the paragraph that we have within all these resumes into words. We could split into sentences if we need to, but most likely we'll be doing the words. So number two, then we need to remove stop words. Number three, stop words. Then punctuations. And then numbers. Then white spaces. Number three, after that, we need to stem and lematize, plus lematize. Number four, we need to transform into structured data using TF IDF, using factorization, using word bag of word, etc. And number five, we need to extract the most common, most co-occurrence words. And so these words, this word is what we are trying to find, to extract what we called latent or hidden topics. Using these words, we're trying to extract a topics. Now, a topic is simply a theme or a template or a theme describing the entire subject of the document. Sometimes you could come with many five topics per document based on the words that most common words of the documents. That is topic modeling in general, and all what it does is trying to extract a meaningful hidden latent topic using the most common words. After, of course, we go through the pre-processing steps, starting from tokenization through stop words removal, punctuation removal, numbers removal, white spaces removal, stemming, lemmatization, transformation using either TF, IDF, factorization, and bag of word. So there are three main models that I use to do that. And before we do that, topic modeling is simply finding the hidden themes from a given documents. That is what we're trying to find hidden themes or hidden topics from the given documents. This documents is finalized, is pre-processed, is cleaned, is tokenized. It's simply in the format of tokens or words. So, and topic modeling is unsupervised learning, in terms that we don't know, we don't have a target variable, we don't have any clue what to expect. We simply trying to find a group of words to represent a topic, and it could be one topic, it could be more than a topic. So this is what I described earlier. Simply we get the data, transform it into tokenization corpus, which is a collection of documents. Then of course we are going to go through pre-processing. I'm talking about tokenization, lemmatization, stemming, then transform into unstructured data, structured data using either TF, IDF, most common one, or bag of words, BOW. Then we apply topic modeling through finding the most common words per document and try to create out of those common words a topic that represent them. For example, if in a document you have words like patient, doctors, disease, cancer, health, then it could be healthcare topic. If you are talking about farm or soccer field, a ball, then definitely you are talking about sport. Then if you are talking about the wars and Washington D.C., then you are talking about politics, etc. So the words in a group of words can make more than a topic, and we are trying to find a topic that is most relevant to a document, which helps us to identify the value or the meaning of that document through the topic it represents. So you might ask, what is the difference between topic modeling and classification? In classification, we have a noun label. So we are going to go through the same process of pre-processing. Then we are going to classify our documents as either yellow or black, red or black, red or green, A or B, either as a spam, not spam, as either an email coming from the boss or email coming from someone else. So you can we can classify into a noun group. That is classification. In topic modeling is unsupervised. After we pre-process the data using the pre-processes pipeline that we covered, we already talked about, then we are gonna group the words, and we're trying to extract a meaningful topic using many methods. We could use LSA that uses dimensionality reduction. We could use LDA that uses probability. We could use HDA, which is an extension of the LDA. This is some models that we are going to cover shortly. Some use cases, some of the topic modeling use cases, we could use topic modeling for resume summarization. You have 1,000 of resumes. We could use, and we are trying to fill a position in data science, for example. Out of this 1,000 resumes, which we don't have time to scan all over them, and now manually, which of course it requires a lot of resources, a lot of effort, a lot of employees to help go through that. So we could use topic modeling to summarize to extract meaningful, hidden, latent topics out of the words used in that resume. So we could use topic modeling for resume summarization. We could use topic modeling for search engine optimization, for recommender systems. We look into the reviews of a product or a service. We analyze pre-process reviews, then we extract a topic out of these reviews, either good or bad, go for it, purchase, don't purchase. So we extract a theme out of the most common words used in that review. So we could also use topic modeling to improve customer support. We have a lot of calls, a lot of complaints from our client. It's really hard to go through all the emails, all the complaints, all the engagement of our clients in the social media, all the reviews, all the comments out there. So it's really hard for 1 or 2 or even 10 people to go through all of this data generated through customers. So what we could do, we could try to load this data in a way or another, and use topic models to summarize it within few words that will give us at least a hint of what they are talking about, and apply fixes or apply improvement based on what we learned in those topic modeling. So topic models also can be used in the health industry. Topic modeling can help us extract useful and valuable information from unstructured medical reports. We know what diseases this patient is struggling with, how he's handling his medication, when and where he needs to see a doctor, how many appointments he misses, how many times he has to use a medicine, when he's supposed to call for a refill. We have all this information in one system, but it's a lot of information for a person to go through. What we could use is dump it into a topic modeling algorithms to extract meaningful topics that we can analyze, utilize to at least start to understand what is going on here and act upon it. So there are many topic modeling approaches. One of them is called LSA/LSI. Latent means hidden semantic analysis, and latent direct link allocation, and hierarchical direct link processing. So as I said, there is a lot of math behind them, complicated math behind them. I am not gonna spend time going through that. It's not gonna help us anyway, regardless. So I'm gonna simply try to cover this concept from the surface, from the helicopter view, from the applied view, at least to help us understand how this models works and how we can utilize them and when to utilize them. So in terms of libraries, there are many libraries, but the most common libraries used in topic modeling, GenSim. GenSim is a popular Python library used for modeling. It's easy to use and provides various topic modeling. It supports LDA and LSI. It does support the LDA, latent direct link allocation, and latent semantic analytics. And of course, HDP is an extension to LDA. So topic GenSim library is a method, or is a library designed specifically to help with topic modeling. There is another library. It's called TomoPy or TomoPy. It's called TomoPy, like pi means Tomoto Pi library. It's a Python library for topic modeling. It's very easy to use, and it includes a lot of modeling, including HDP model and LDA model. So it does support LDA model and its extension, HDP. Of course, there are other libraries that designed for topic modeling, and one of them is the most common scikit-learn or machine learning algorithm, machine learning library that is scikit-learn. Okay, now let's talk very short about latent semantic analysis. So what this this processes does. So number one, LSA is also known as LSI or latent semantic index. It uses the bag of word. After we process our data, we extract and we transform the unstructured data to structured data using bag of word. Simply means every document, how many unique words that we have. So every word comes with its a number that represents its occurrence. It could be 1, it could be 1,000. And once we have bag of word, then we are going to reduce the dimensionality using a package called SDV, singular value decomposition. This SDV is similar to the two packages or two methodologies or algorithms that we learned in the program, LDA and PCA, principal component analysis, and LDA, linear discriminant analysis. So there are these two. So LSA or LSI, it does use a methodology or an algorithm to reduce dimensionality, keep only 2 dimensionalities, and based on that it looks for the similarity between documents. This is a nutshell, of course, without going into the mathematical behavior of this library. So a question that, sometimes, we in a document you could have many words, and out of those words we could extract many unique words or most common words or current words, and out of these words altogether we could extract many topics. So the question that would come to your mind is, how many topics should we extract? What is the optimum number of topics that we should extract out of documents? Again, if you guys remember what we learned in the K-means clustering, and so we know about the optimal way of determining the optimal number of clusters to create. We remember the elbow method, and cell-width method. This can be also used to determine, cell-width coefficient is one of them. It could be used to determine the number of topics. To start with, you could create, for a document up to 10 topics, 20 topics, which could be used to exactly sorted, of course, with from the highest to lowest, to help you understand the true theme of a document. So that is LSA in a nutshell, as I said, without going into the mathematical behavior, which I don't really want to go through. And then the second one is called latent directlet or directlet allocation. So there are 3 distinct words here. Latent means hidden. So the word latent indicates the model discovers yet to be found. We don't know it yet. I know we have we have 10,000 words in the documents, and out of that 10,000 words, there are at least 1,000 unique words and probably 5,000 most common words. If we were to combine, or if we were to extract, to combine all these unique words or the most common words, we could extract a meaningful topic. So latent is hidden. It's not known yet. So it's implicit. So we're trying to discover it. That is what the first word means. The reclit is an indicating assumption, or it's a distribution. It's a probability, and the allocation, of course, it talks about the indicate the distribution of the topics across in the entire document. That is what this LDA all stands for, is trying to discover meaningful topics out of the most common words of a document once pre-processed using the distribution, the Dirichlet distribution, which is a mathematical distribution, mathematical terminology. So what is this LDA is used for? Simply this is a topic modeling. It's used for summarizes the entire document in few meaningful topics. And how it's related to machine learning, text mining, of course, the topic modeling, as I mentioned earlier, is unsupervised learning. We don't know what to expect. We don't have any labeled data. We don't have any supervised data. It's unsupervised. We don't know what to expect. We don't know what yet to be found. We don't know how many topics to found, how important topics that we could find. So it is unsupervised learning. But once we extract a meaningful topics out of these documents, we could transfer this the whole learning from unsupervised into a label. Now we could label our documents using the topics and transform it into supervised and apply supervised learning techniques. So I gave you an example of data science. When you hear data science, what comes to your mind? Of course, it comes to your mind many words related to data science. So data science has topics, contains many words to make it, and documents contains many words. Is there a way we can find the similarities between words that makes a topic with words that we have in the documents to extract a meaningful hidden topic? So LDA is one of the most popular topic modeling method. Each document is made up of various words, and each topic also has various words belonging to it. So data science has pandas, has NumPy, matplotlib, Seaborn, and your resume has pandas, NumPy, matplotlib, Python, etc. Your resume has words, common words. Your topic models has common words that we know. So if we have 10 topics and we have thousands of resumes, or if we have 10 positions that we want to fill, like data scientist, data analyst, DBA, developer, for example, and we have 10,000. So these positions are our topics, and these topics, of course, requires some skill set, and those skill set is the words that makes the topics, and we are going to look for those skills or those words in the documents that provide to us, in the resumes that provide to us, to extract a meaningful topic that we could use to label that to label the resume and determine its feasibility or its usefulness to go forward for the position applied for, or simply move on and to the next resume. So for example, for a document we are going to extract many words. Like in document 1 we have word 1 appears 1, word 3 appears 3 times, word 5 appears 5 times, word 88 appears occurs 88 times. Then document 2 and 3 and 4, resume 5, resume 6, 7, all the way to resume at 10,000, for example. And we have a list of topics. So this is a data science, and data science is contains pandas, NumPy, matplotlib, data science, analytics, and these words have a certain weight that we can rely to apply similarities. So that is LDA application. We could use an LDA again for whatever for whatever we cover for LSA or LSI. The same applies with LDA. We use it for text mining, for text clustering, for incident tracking, for text classification. We use it for of course finding, summarizing the theme, summarizing the entire content of a document. And finally, hierarchical Dirichlet process, HDP, is basically an extension of LDA. designed to address the cases where the number of mixed component, the number of topics. Sometimes you are going to get more than a topic per document, and without using, of course, the conditional probability, the a priori. So this LDA comes into the place to fix the shortcuts or the shortcoming of LDA, without, of course, going into the details of how they work. This is simply a surface or natural explanation of what these three algorithms does or do to help extract the insight, extract meaningful topics that would help us to reduce the amount spent in a processing and a task. Let's say filtering out 1,000 of resumes. So hopefully this topic modeling is clear. I tried my best to explain it as much as I can. My sincere apologies. I'm almost lost my voice. I have a crazy weekend. I had a class from 9 to 11 to 12. Then I had another class from 1 to 3, and this is the third class, probably from 3 to 5. So I feel like I'm losing my voice. So my sincere apologies. Okay, so now we have at least an understanding of what is the topic modeling, what the algorithms behind it, and now let's move on to a tutorial. We are gonna go to a Jupyter notebook. Yeah, we are gonna go to Jupyter notebook, and I forgot to share the document with you guys, but I promise I will do it after the class. So yeah, the first thing I'm gonna do, as usual, is I'm gonna start over, clear out the output, and I'm gonna zoom in a little bit just to make it zoom out a little bit. Hopefully it's clear. If not, please say something in the chat. I will be more than happy to address it before we proceed. So the first cell talks about what is topic modeling. It's basically what I talked about in the presentation. I talk about all the modeling, LSA, LDA, HDP. These are the most common algorithms used in the topic modeling, either using GenSum library or I forgot it's called the toponymy probably. No, it's called the tomotopy or tomotopy library, and of course you have scikit-learn. So now we are going to analyze. Not I was planning to analyze the word cup, but for a reason the code it's not working. So anyway, we are going to analyze articles. Let's take a look into a data set first. So this is the data set that we are going to use. Not one. Articles. So we got a lot of articles in this text file. 1,000 or even I don't know how many words we have, but a lot of it's, even if, as you see here, it's huge, and it takes a while to process. Unfortunately, I cannot stop recording to wait for it to load, but we are gonna leave with it for a moment and we'll come back to it. So the first thing we gotta do is number one, we are gonna import all the packages needed, and some of these packages you have to install them. Like for example, the GenSum library is the library that we used for topic modeling for Python. You got to use pip install the library, run it. I am not going to do it. If I do, you are going to see that I met all the requirement. So it does say a requirement already satisfied, so I did it, and they have all my packages. So I'm going to import for the GenSum the corpora. This is a method that we are going to use to transform, to organize, to digitize, and make our documents searchable. Then we are going to use, we are going to import from the GenSum LSI model. This is the model that uses the dimensionality reduction methodology. Then of course we are going to use from NLTK the pre-processing. We are going to import the regular express tokenization, the stop words, the pause stemmer, and then we are going to import the coherence model. This is another model or this HDP model, I'm sorry, LDA model as a second topic modeling. And of course we are going to import matplotlib to visualize in case we need to. And we are going to import a method to transform the structured data into unstructured data. We are going to use TF-IDF and TF-IDF vectorizer. This is one of the methods used to transform unstructured data into structured data. And then we are going to import a truncated SVD. This is a method, a library or an algorithm used to reduce the dimensionality of your data. It's similar to PCA, principal component analysis, and in LDA, linear discriminant analysis. Okay, the first thing we gotta do here is to read the data. Okay, we are gonna import all the packages needed, rules and modules. And while I'm doing that, let me take a look into data. Yeah, this is my data here. Actually, it's very no, it's a huge. It won't open. You see, it won't open. It's very huge. I mean, it's a huge. I don't know how many words we could find out, but it's a huge data set. So after that, we are going to read the data using the OS method. No such file. I know because no such file. Maybe it's data. Okay, change that. Here we go. Yes, I moved it to a folder data. So now we'll read. We imported the packages needed, libraries. We'll read our data, and now we need to pre-process this data. Number one, we are gonna use a regular express tokenizer. We are gonna tokenize it, and we are gonna remove anything that is not a string. So we are gonna remove any special characters. Probably we are gonna remove any punctuations, any numbers, and we are gonna keep only words. And after that, we are gonna transform everything to lowercase. We are gonna remove stop words. We are gonna simply tokenize into n-gram, means one word at a time. We could do two gram, n-gram equal 2 or 3 or 4, means we could do 2 words, 3 words, 4 words, etc. But we are going to do only one, and at the end we are going to tokenize. And this is applying TF-IDF vectorizer, which is, as I said, a method. It does not only transfer unstructured data to unstructured data to structured data, but it also allows us to pre-process the data. So we are going to pre-process the data with one click. And let's take a look into our data. Hopefully we'll be able to read it. So it's an object. It's simply, this is, here we go. It consists with 1,435,888 sort element. So in a compressed sparse row, it's very compressed because it's a huge, so we won't be able to read it. So now what we have to do is we need to reduce the dimensionality of this data by performing SVD, SVD using the truncated SVD algorithm from scikit-learn. So first of all, we are going to determine how many components we are going to keep. If you guys remember the process of reducing the dimensionality using LDA and PCA, is you have to determine how many components to create. The less, the better. In LDA, the most common method to the most optimal number of reducing the dimensionality is simply creating 2 principal components, or creating only 2 components out of whatever data that you have. So then we are going to apply, we are going to reduce the dimensionality by simply finding the most, extracting 10 new components out of this existing given components. And this is a model, and we want to iterate through this number of documents of words at least 100 times before we come with the conclusion of the 10 most important component. So my data has been reduced, and now we are going to extract the topics. We are going to extract the topics using the LSA. So we are going to use the LSA, which is a library. Which is a library used or designed for topic modeling using a word in a bag of word. Okay, I'm going to run it very quick. I really and this is what it creates, what comes up with in topic 0. It has S, Trump, said, AU, T. Of course, when what happens with S and T, standalone, we might need to remove standalone features or standalone words. So when we reduced when we pre-process the data, we could have done something wrong, and when we reduce the dimensionality, we could have something worse. So, but this is the out of these 1 million, almost 2 million words. This is the out of this all the documents. So there are many documents out of this. As you see here, this is one document. This is another document. And this is the third document. This is 4 documents. So out of this, all these documents, this is the most common, topics. So all these documents, they are talking about Trump, Clinton, and league, season, league again, season, bank, healthcare, corner, yard, Facebook, internet, films, movies, women, director, labor. So at least we have an idea of what this all this huge amount of data dumped into us that would take us a very long time to figure out what they are about if we were to scan them, if we were to use them. So within a few clicks, we were able to at least determine what all these topics are about. So I probably please confirm if we should stop here, because I really feel that I need to. I cannot proceed anymore. Tell me if we should, if you guys want me to proceed, I can do it. Otherwise, we can stop here and we'll continue next week. Next week we could do LDA, and we are gonna do sentiment analysis. Please confirm what you guys want me to do. I am very open. And the chat, please say something. If you want me to use the other algorithm, I can do it, because I'm very tired talking from 8 o'clock in the morning all the way to 5. Yes, so let's stop here, guys. I cannot proceed. My apologies, but I'll see you guys next weekend, next Sunday. Next Sunday we are gonna finish this topic modeling, and we are gonna move into another topic, very critical, sensitive topic, and that is sentiment analysis. We are gonna skip building chatbot. It does require a lot of resources, a lot of training, and we are gonna skip text generation. We are gonna move straight to sentiment analysis, and that could be the end of the program. We will find out, we'll figure out. Okay, folks, my sincere apologies for not being able to complete today's session, but I promise to go through this next weekend. And okay, guys, that's it for today. I'll see you guys next week. Until then, you guys have a great evening, great rest of the week, and bye bye everybody.